talk about the idea of symmetry. So symmetry can be loosely defined as having a figure that has a match in some way, that there's something that we can do to it that will create a completely congruent and matching figure. So there are a couple different kinds of symmetries. So just as you look at these four pictures, you want to think about which ones of these do we think have symmetry. So I really loosely defined symmetry. So thinking about what you have heard of that word before, or just the idea of that there's something that we can do to it that will still create a congruent figure. What do you think about these pictures and whether or not they have symmetry? So we are going to talk about two different kinds of symmetry. One type of symmetry is a line symmetry. So when we think about a line symmetry, what we're going to think about is a way that we could fold the object. So as we look at that first picture, which is kind of like the eye in the circle, it's a CBS logo. As we look at that logo, what ways do you think we could fold that logo that we would then have a perfect match on each side of the line? So one way we could fold that logo would be through the horizontal line. That if we fold that horizontally, imagine having done it in paint, that paint splotch is going to perfectly match on each side. Okay, so we could fold it on a horizontal. Another way we could fold that one would actually be on a vertical. That if we fold it closed like a book vertically, that the left and the right half of the image perfectly match each other. Are there any diagonal lines? Sometimes we can fold on a diagonal line. Well, if we fold on a diagonal line, I don't think that paint's going to perfectly match. The two circles would, but that eye, the white parts aren't going to totally match up. So that one, it looks like has two lines of symmetry there. The next one, which says the word mirror in kind of a clever font there, has mirror symmetry, or a line folding symmetry through a vertical line down the middle, that if I fold that close, it perfectly matches on each side through that vertical line. Could I do a horizontal line on this one? No, it looks like those little tails don't have a match on the bottom, so a horizontal line wouldn't work. And if I try a diagonal line, we can just kind of draw on a diagonal line to give a visual here. And let's see if I try to fold it along that line. It doesn't look like what's on the two sides of that line match up. So that one doesn't have any diagonal line symmetry on it. All right, so now as we move on and look at that next one, which is the recycle symbol, can I draw any lines of symmetry here? Well, horizontal, if I try to put a horizontal line through there, no, that doesn't match on the two sides. If I try a vertical line through there, kind of miss the middle, but still we can see it doesn't really match. The arrows don't match up on each side, so that doesn't work. What about any diagonal lines of symmetry? If I try a diagonal line there, now that arrows still aren't matching, it doesn't look like we can fold this one. This one does not have any folding symmetry to it. And then that last one, which actually says the word symmetry, again in kind of a clever font, if we try a horizontal line, no, top and bottom don't match. If we try a vertical line, yeah, I kind of missed the middle again there, but still we can see top and bottom don't match, or left and right rather don't match. If we try a diagonal line on that one, I'm not feeling too great about that either. So that one doesn't look like it has any lines of symmetry. So I said there's two different kinds of symmetry we're going to talk about, and this one is this folding type of symmetry. The other is a rotational type of symmetry, and that's the idea that we want to take that figure and turn it around and have it match. Now, one disclaimer on this, 360 degrees would bring it back where it is. So we don't consider that symmetrical because that's just exactly it. You really haven't changed it at all if you're going in the full 360. So 360 symmetry, not a thing. We won't think about that. But is there some other angle that I could turn the figure and that it would create a congruent figure? So we'll start back with the eye again. Could I take that and could I turn it any amount of degrees and have it end up exactly the same? Well, if I turn it 90 degrees, well, then the eye is pointing kind of the other way. So that wouldn't work. If I turn it 180, that's like turning something upside down. So when we think about 180 symmetry, what you kind of want to do is imagine like you're holding the paper and turn the paper upside down, and does it look the same? And if I turn my paper upside down on that eyeball, it would look the same. So we're going to say that this one has 180 degree rotational symmetry, that I could turn it 180 degrees and it would look exactly the same. Mirror there. Well, if I turn the paper upside down on that one, that's not going to look the same. If I turn it 90 degrees, it's going to be tall instead of long. Weird measurements like 60 degrees or 45 degrees, I don't really think that's going to happen there. Going on to that recycle symbol, could I turn that some amount and have it line up the same? Well, not 180. If I turn my paper upside down, I'd have kind of two arrows at the top and one at the bottom. That kind of triangle would end up upside down. It's essentially a triangle, right? So what could I do with a triangle? Well, triangles have 3 points. If I take 360 and divide it by 3, I get 120. I could turn this thing 120 degrees, either way, clockwise or counterclockwise, and I would end up with a matching figure. I could also turn it to the next corner, which would be another 120, so that'd be a 240 degree. That would work as well. So I could turn it either 120 or 240 degrees, clockwise or counterclockwise, and end up at the same thing. I could turn it 360 as well, but then it's literally exactly the same, so we don't count that as symmetry. And the last one, that word symmetry, could I turn that? Well, if I turn it 90, it's going to be long, tall instead of long. 180, well, if I turn my paper upside down on that, it does look like they made that Y kind of fancy so that it would be the S, and same thing with like the T and the Y, the nice little tails they have there. This thing, I could turn my paper upside down 180 degrees and it would result in a congruent figure. So that one has 180 degree symmetry. I wrote 180 there, but it's not showing up for whatever reason. So just note that that symmetry does have 180 degree rotational symmetry there. Okay, so let's look at a couple kinds of problems that you'll have here. The first kind asks you to identify which figures are symmetrical, and we just have some pictures here. So on these, we're mainly thinking of lines of symmetry, not rotational symmetry. So as you kind of look at those. Now, one thing to note is make sure that you note that the questions do say choose all answers that apply. So as you're looking at them, don't be like, ooh, A, and then just go on. Make sure you look at all of the answers because for some of them, you might select more than one answer. The next one wants us to identify the line of symmetry. So it shows different lines and it says, would that be a line of symmetry? And the idea there is if I try to fold it on that line, am I getting a match or not? Okay, so for those, you're going to think about whether or not those lines of symmetry match up. All right, so let me know what questions you have as you are working on this assignment, and I will see you guys again soon.